Okay. Pen. So good morning everyone. Today let us try to discuss the AP Eamcet paper of July 7th and 2nd shift. So please try to open your question papers. Hope you have your question papers. So let us try to discuss the second shift of July 7th physics paper. So we will be trying to discuss the concepts behind them as well, so that it will be helpful for your next exams. So first let us start with kinematics. So kinematics got a good weightage in this set as usual. So please try to open your books and try to solve. Question 82, hope the same is the number with you as well. So the question says that a car is moving in a straight line and is brought to rest with a distance of 200 meters and the time taken is 10 seconds. Find the initial speed of the car. Okay. So the distance given s is equal to 200 meters. Time t is equal to 10 seconds. And the initial speed is being asked. So from the statement that the car is brought to rest, we will get to know that the final speed is 0. So using these three variables, we are supposed to find u, so this is one of the formula we have. This is the other formula we have. These are the three fundamental formulas we have. Which of them can be used so that we can find the initial velocity using the other variables? So we are supposed to use these three equations and find the final answer. So what all can be used? From first let us try to use this equation, okay? So 0 is equal to 0 minus u square is equal to 2 into a into s is equal to 200, right? So what do we get from here? 400A minus u square is equal to 400A. So still, what else do we have? We can use this, right? Here v is equal to 0. U is equal to, we need to find, plus acceleration not given. Where is it not given? A is equal to 10. So from here we get A is equal to, U is equal to minus 10A. Okay. So what do we need? We need U. So we got a relation between U and A, U and A. So we need to find U. So how? Try to think. Here we have 2as, right? Okay, we multiplied as well. Come on, try. How do you find u? See, here we can find A, right? A is equal to minus u by 10, right? So substitute A here, you get here. What is A there? Minus u by 10. So try to cancel out. What is u? Right? So that's how we need to proceed. Like, we cannot get solution directly from one equation. We need to use two equations so that we will be getting the u, that is equal to 40 meters per second. Hope you all of you got it. Right, hope this question is clear with everyone. So these are the basic fundamental equations if we try to use with the kinematics of equation, kinematics of motion. So other fundamental equation, that is Sn is equal to u plus a into, what is this Sn? Displacement in nth second, u plus a into n minus half. So these are the fundamental equations if we try to use. So let's try to look at next question. So question number 83. Please try to open your question number 83 and try to solve. The question says that a ball is thrown up from the top of a building at an angle of 30 degrees to the horizontal with an initial speed of 20 meters per second. the ball strikes the ground after 3 seconds. So let's try to predict the motion of the ball. So it tries to fly this way and hits the ground. See, if you try to erase this portion, it will be a normal projectile motion. Okay. So now the ball is thrown up from a height h. So the question is, the time taken for the ball to strike the ground is 3 seconds. The question is, what is the height of the building? So how do you solve? Yeah, come on, try to solve this question. So what all equations do we know? First, what do we do? Let's try to resolve this velocity. Velocity along horizontal direction will be 20 cos 30. Velocity along vertical direction will be 20 sin 30. So there are different ways in which you can solve the problem. So how do you approach? Try to solve this question. Hope you still have exams left. At least similar concept will repeat. You may not expect the same question, but this is a fundamental question that is getting repeated every year almost. So please try to solve. So how do you find time of flight if it is a normal projectile? It is 2 into velocity along vertical direction by g, right? So after time of flight, our so-called ball will be here. So if we can find the remaining time it traveled, we can find the distance height h. Okay. So first try to find the time of flight. Flight, considering it as a normal projectile, it will be less than 3 seconds obviously. So what will be that? So try to solve this. You will get something as 2 times velocity along y direction. 20 sin 30, 10, right? 20 sin 30, 30 by g. G we take as 10. So sin 30 half. So we get 2 seconds. The time of flight till here will be 2 seconds. At t is equal to 2 seconds, our ball will be here. So the remaining time, that is 1 second. It will travel the remaining path. So the Vy here will be equal to Vy at this point. We can take that as a standard, and from our kinematics of equation, V is equal to V square minus U square is equal to 2as. We have one equation. So what else can we use so that we can find height h? So we need S, right? So in what all equations do we have S or height h? Okay. Okay. Still, these are the two equations we have S. Ut, right? Okay. So I guess you can use this equation because we need S, we have time t, remaining time 1 second, right? Remaining time 1 second, velocity v, that is 20 sine 30 half a t square. So if you try to find it, we get as 10, 20 sine 30, right? Half 10. Again time t, t is not 3 seconds, that is extra time that traveled 1 second. So how much do we get? 10 plus 5. 15 meters. So I guess option 2, according to my paper, 15 meters. So the height is 15 meters. See, if you try to throw a ball from a height of h 15 meters, it travels for time t equal to 2 seconds and reach the horizontal equivalent, and then it falls down. So the time of flight, so first we try to calculate the time of flight, that is t is equal to 2 seconds plus the extra time that it traveled through the height of the building, that is 1 second. So if you try to find, we get 15 meters. Hope you are getting my solution. So there are different ways of solving. This is one way. If you can find other way, it will be quite better. So this is one way of solving the question. See, this is also a problem that belongs to kinematics. So hope you are clear with this question. So hope you are clear with this question. Let's try to do another problem from the same kinematics. Right? That is question number 84. It says that a particle is moving in a circular path with a constant speed v, and it changes from, okay, the question is given this way. It makes an angle theta. So from point A to B, let's consider this as point A to B. So a particle is moving in a circular path with a constant velocity, constant speed, sorry. The key words given are constant speed, the question is its change in velocity as it moves from A to B. So does velocity really change? It is being said that it moves at constant speed. So what is the difference between speed and velocity? Let's try to look at that first. Here in question it is said that constant speed, and it is being asked the difference in velocity. So how do you differentiate speed and velocity? Velocity has both magnitude and direction. Speed has only magnitude. Here it is said that speed is constant, which means that the magnitude is constant, but velocity includes magnitude as well as direction. So the direction keeps changing. You may think that change in velocity will be 0, but magnitude only is 0. Change in magnitude is only 0, but not direction. So now it's a part of vectors if we try to carefully understand. So let's try to do this. So it is something like this. V2, V1. Here magnitudes are same but not directions. So the question is delta V, that is V2 minus V1. So how can we proceed? So if you try to look at magnitude, V2 square minus V1 square, sorry, plus V2 square. Okay, you can write either way. 2V1 V2 cos theta. Okay. So this is the magnitude of the difference between two vectors. So what is V2 and V1? Both are of same magnitude. So V square plus V square plus 2V square cos theta, right? So if you try to take V square out, okay, let us not directly jump. Let us go step by step again. So what do we get? 2V square minus 2V square cos theta, right? So if we take 2V square out, we get 1 minus cos theta. So now that your trigonometry comes into picture. 2V square. So how can we write 1 minus cos theta? 2 sin square theta by 2. So you need to know the basic trigonometry. So maths and physics are completely interlinked. So you need to know basic trigonometry. So what do we get finally? 4 V square. Okay, let's. I'm trying to do an elaborate process. So this is what we get. So I guess we have option as well. So this is, so generally what exactly, see generally we try to think that the difference is 0 because it is being said that constant speed. But velocity is not just speed, it also includes vector, that is direction. So see the difference that we get due to the change in velocity. So this is one of the tricky question in, it falls both in kinematics and vectors as well. So you need to have basics of both kinematics and vectors. Hope you are clear with this question. Just try to note down if you have any doubt. So we are trying to find the difference in magnitude. Okay, that is the reason we got this change in velocity. Okay. At least note down. So let's try to look at the other questions from kinematics. This is question 85. It is said that a body of mass 2 kg is placed on an inclined plane that makes an angle 30 degrees. The coefficient of friction between the box and the inclined plane is 0.2. The force F applied on the box perpendicular to the incline to prevent the box from sliding down. So the minimum value of F. The question is, what is the minimum force that is need to be applied so that the box does not slide down? So how do we solve this? Try to think and do. So let's try to resolve the forces. So this is mg cos 30. This is mg sin 30. What is this? This is normal force N, and the other force, that is F. So are these only forces? Yes, we have friction force as well, that is acting opposite to the direction of motion as the block is trying to slide down. Okay. So we need force F so that the block should not slide down. That's our main target. So if F is equal to mg sin theta, friction force is equal to mg sin theta, the net force along the inclination will be 0 and the body will be at rest, right? So what is F? F is equal to mu n. So try to solve. So what does n stand here for? N is equal to mu plus mu into mg cos theta plus F. See, this is the equation that need to be framed. If you can frame this equation, you are done. Because we know mg, we know sine angle, we know mu, You know mg cos theta, we need to find f. So if we can try to apply the Newton's equation along the inclined plane, we can solve the question. Hope you have copied this question. So the weight is 20, taking g as 10, sin 30 half, mu is equal to 0.2, mg again 20, cos 30 root 3 by 2 plus f. So try to solve and find f. So what do we get? 10 is equal to 0.2 10 root 3 plus f. So here we get 50, right? 17.3 plus f. So f is equal to 50 minus 17.3, that is equal to so hope we have this, yes, we have this option as well. So this is how we try to solve the question. So if you can frame this equation the first attempt, you are done. Remaining part is just calculation. Hope you got the question. So if you want to look at the question completely, the question given is in mass given, coefficient of friction given, F minimum is being asked. The force, minimum force required to keep the block at rest without getting slided. So if you can frame this equation, you are done. So let's try to solve the next question. See, such concepts will get repeated in your future exams as well. So make sure that ability to make the equation, to form the equation, will solve half of the problem. Which one? So let's try to go to next question. Even this question is from mechanics. It is question 86 in my paper. So the question is, which of the following is true about the coefficient of static friction mu s and the coefficient of kinematic friction mu k? This is basically a theory question. So the options given are both are equal. Option B, mu s greater than mu k. Option C, mu s less than mu k. Option D, depends on applications. See, what do you mean by mu s and mu k? What do they stand for? So mu s stands for static friction. So mu s is the limiting friction actually. Okay. Mu k comes into picture in dynamic. The body is in dynamic motion. Okay. So hope you remember that graph. This is the limiting friction mu s and this goes as mu k. So the mu s is always greater than mu k. If you can remember that graph. Mu s, what exactly it stands for? Like the maximum amount of resisting force that a body can provide when it is at rest. Okay. Mu k is proportional to the amount of force that it provides when it is in motion. Okay. Mu s varies from 0 to, limiting friction varies from 0 to mu s times n. So that if you want to get the limiting friction, you need to multiply mu s with n. So the coefficient of static friction will always be greater than coefficient of dynamic friction. So this is a direct question. Let's try to look at another question. A body of mass 20 kg is displaced by x is equal to 5d square. Where t is time in seconds. And force is being applied. So the question is, what is the ratio of work done in 3 seconds to work done 5 seconds? So how do you find, using these two equations, how do we get ratio? This is bit tricky question, is not a direct question. So how do you find work done? So even this falls in part of work power energy that belongs to mechanics. So how do you try to solve this? So try solving. What all equations can we use here using your work power energy concept? So how do you write work done? There are different forms in which work done can be written. Work done is equal to force into displacement, right? Right? This is one form. So what all other forms can be used to find work done? Change in kinetic energy, not potential energy. Delta Ke is equal to work done. Okay, still Still, what else can be equated to work done? So like, can we use this delta KE concept here to find the work done? Okay, try. How do you find kinetic energy using these two conditions? So like, we have displacement, right? How do you find what is delta KE? Half m into v final square minus v initial square, right? Then how can we find velocity from x is equal to phi d square? What is so here x is nothing but displacement. So to find velocity, we need to differentiate displacement, that is 25t, right? Velocity at time t is given by, sorry, phi to the 10t, right? Phi to the 10t. So velocity, in order to find work done, half m velocity at 3 seconds. What is velocity at 3 seconds? 10 into 3, 30. 30 square minus velocity at 0. In the similar fashion, 5 seconds, 50 square minus 0 square, right? So if you try to simplify, what do we get? So hope you have that option. So that's how we get, see, like, there are different ways in which work done can be written. Hope this question is clear, right? So let's try to look at next question. Let's try to first cover the questions from mechanics. So the other question is, says that a wheel undergoes a constant acceleration from rest. So keywords, u is equal to 0. Here it is moving in circular motion, so we need to take omega initial. It has a constant acceleration, alpha. The angular velocity at 2 seconds is given as 3.14 radians per second, okay? The acceleration is abruptly stopped at t equal to 20 seconds. So from 0 to 20 seconds, it accelerates with the angular acceleration alpha. So next from 20 to 40 there is no acceleration. So what is the question being asked? The number of revolutions the wheel makes from t equal to 0 to t equal to 40 seconds. So number of revolutions. So the number of revolution the wheel makes from 0 to 40 seconds. So how do you find? So it is not a direct question, like you cannot directly apply formula. You need to work out on couple of formulas to get the final answer. So try to use the equations of circular motion. So try to solve that. So first try to copy the question and attempt the question so that at least you will get an idea. So what all questions, so what all equations do we have? Same. V square minus u square 2 alpha theta. If you try to so these are all the equations. Still what all do we have? See, these are the three basic equations that we have. These are similar to linear motion. So what else can be done so that number of revolutions can be found? So we need to find theta here first and theta divided by 2 pi, so that we will be getting number of revolutions, because each revolution, one revolution is equal to 2 pi. So first let us try to find theta for 0 to 20 seconds and 20 to 40 seconds. Let us try to add them up and divide it by 2 pi so that we will be getting the answer. So first from 0 to 20 seconds we have some acceleration. Okay. So what is the value of that acceleration? We don't know, right? So how do we find? So first we need to find the alpha. So using these two equations, let's try to find alpha so that we will be getting things. So omega final, omega first let us try to find the alpha. Okay, what is WF after 2 seconds? 3.14. So what it started from? It started from 0. Alpha after time equal to 2 seconds. So what is alpha? pi by 2, right? 3.14 divided by 2. So we got alpha. So once we got alpha, it will be easy for us to find theta from here, and okay, you can only use this equation and find theta. Try to find theta using this equation for first 20 seconds. See, even after giving hints, you need to do at least. So first let us try to find theta for theta for 0 to 20 seconds. Okay. So how do you find directly? Initial velocity at t equal to 0, let us take from rest, okay? 0 plus half, we got alpha, that is pi by 2, and t square, 20 whole square. So hope you are getting why we are taking 20. We are trying to first find the theta between these two, 0 to 20 seconds. Because there is alpha present here, there is an angular acceleration present between 0 to 20 seconds, and there is no angular acceleration from 20 to 40 seconds. Okay? Why? 2 there, okay. See, here in question it is given that omega after 2 seconds is equal to 3.14 seconds. 14 radians. See, this is question given. In question it is given that initial is 0 and after 2 seconds the omega will be 3.14. So I am using this equation here, I am using this statement and trying to find alpha. Final omega will be 3.14 radians per second after 2 seconds. Initial will be 0 as it is starting from rest, alpha, and after t is equal to 2 seconds. So that is the reason I took 2. Hope you got. See, there are multiple concepts involved here, so you may get questions. You may get questions from any part. So first let us try to complete this, okay? So finally we got theta is equal to 100 pi for 0 to 20 seconds. Now let's try to find theta for 20 to 40 seconds. As there is no acceleration, we are trying to use, so how shall we find from theta from 20 to 40 seconds? As alpha is 0 here. Alpha is 0 because there is no acceleration. So how do you find the remaining theta for 20 to 40 seconds? So we need to find omega after 20 seconds. Omega after 20 seconds. Initial will be 0, Wi plus alpha t. So it will be 0 and omega final at 20 seconds is equal to what is alpha? Pi by 2 into 20, that is 10 pi. So omega 20 seconds. So this will continue. Omega at 20 seconds will continue because there won't be any kind of acceleration. And for remaining time 20 seconds is equal to 200 pi, right? So the total displacement covered from 0 to 40 seconds will be 100 pi plus 200 pi, that is equal to 300 pi. So what are we trying to find? We are trying to find the number of revolutions. So one revolution is equal to 2 pi. So in order to find number of revolutions, divided it by 2 pi. So how many revolutions do we get at end? 150. So hope you have this option. See the concept involved. We are trying to use multiple. See, the questions are not direct. We are trying to use multiple equations and finding the answer. Hope. See, first what exactly we have done, we have tried to find the theta for 20 seconds and 20 to 40, then we added them. Okay. See, I guess you have exams left to write, right? Definitely concept will get repeated. This is not something you will not see in your lifetime. See, in your near future you can see these questions. So at least if you try to have an idea, you can attempt something. So try to focus. Hope this question is clear, okay? What radians? See, pi is, we are in radians. See, like 2 pi radians. We are in radians right from the beginning. We haven't converted it anywhere to into other form. Like right from the first line, we are in radians. So we got the answer directly as 150. Okay. So let's try to go to next question. Let's try to look at the properties of material. Questions from properties of material. So 1.5 rod. Thousand kg, it is suspended to 1000 kg. The other end is, the length of the rod is 50 centimeters. And its cross sectional area is 1000 mm square. The change in length of the rod due to the weight attached. So how do you solve this? This is direct question. So what are all the relations involved with these equations? Please try to recall them. See, what all do we know? Stress is equal to Y strain or E strain. It's nothing but Young's modulus. So how do you write stress F by A? F by A is equal to E into delta L by L. So the data that is given is Young's modulus E or Y, whatever you call it, 2 into 10 power 11 Newton per meter square. Acceleration due to gravity G is equal to 10. So we need delta L, right? Delta L is equal to F L by A. So what is F? Weight 10 power 4. Directly I am writing M into G, 1000 kg into G, meters per second square. Where length L is equal to 50 centimeters. I am trying to write it in meters, 0.5 meters. So what is area? 1000 mm square. Okay. What is Young's modulus? 2 into 10 power 11. See, here we need to take care of units actually, okay? See, what are the units of F by A? Newton per mm square, right? We have area in millimeters, right? So if you try to convert this 10 power 6 into Newton per meter square. So 1 Newton per mm square is equal to 10 power 6 Pascal, nothing but 1 megapascal. So we need to take care of units here. So what do we get? 10 into 10 power 6 Pascal, because this is in Newton per mm square. Newton per mm square. I am trying to convert it into Newton per meter square, because here we have this in Newton per meter square. 10 into 3 zeros gets cancelled and 10 will be left into 10 power 6 into 0.5 by 2 into 10 power 11. So how much do you get? Yes, 10 power 6 plus 1, 7. Here we are left with 4. Okay. So 0.25 by, like, directly I am trying to write 0.5 by 2 by 10 power 4, we will get something meters. So here it is being asked in mm, right? So you 0.025 mm. Hope you got the units conversion, like 10 power 3 becomes millimeter and 1 0 goes up and 0.025 mm. Units. Which one? See, like you are trying to apply the formula F by A is equal to stress is equal to E strain, right? So this is direct question, but you need to take care of units like. See, F is in newtons, area is in mm square. So we need to convert it into meters. So Newton per mm square is equal to 10 power 6 into Newton per meter square. So I am trying to convert this F by A into this F by A. See, you are left with 10 here. So I have written 10. Newton per meters mm square is converted into 10 power 6, okay? So like there is nothing much here, only this is the only key point if you want to look at. So we get the answer as 0.025 mm. Hope this is clear. Let us try to look at the other problem. Copy, you want to copy? So there is, I guess there is nothing to copy here as well. So only those two things that this is, if you are aware of this, you are done. So if you are aware of this, you can easily solve this problem. Let's try to look at the other problem. I guess remaining problems are direct formula based. Let's try to look. So a cylindrical tank having a large diameter is filled with water to a height h. A hole is made at the bottom whose area of cross section is 5 centimeters square. And it allows the water to drain out. Question number 96. I guess it is same with everyone, like, right? So 96, question number 96. So let us try to look at the problems where concepts are involved first, and let us then get back to direct questions, okay? So the question is, a hole is at the bottom, and the water drains out at the rate of water flow rate 2 into 10 power minus 3 meter cube per second. Right? So this is the question given. Is being asked what is the height h. So how do you solve? See, this is direct, simple question. Try to solve. How do you solve this? So what are the different ways? See, how can we write flow rate as area into velocity, where cross section area is 5. Let us try to convert it into meters. 10 power minus 4. Okay. Then velocity, we have 2 into 10 power minus 3. So how do you find height h using velocity v from fluid dynamics? So this is what we got from the given data. So we all know that from Bernoulli's equation, v is equal to under root 2gh. We get this from Bernoulli's equation. Okay, this is the direct output that we can take from Bernoulli. So if you try to solve this, 2 by 5, 20 by 5 v is equal to 4 meter per second. Hope this is correct. Just direct simplify, man. 2 by 5, 10 power minus 3 by 10 power minus 4. You will be having 10 power minus 1 down. It goes up. 20 by 5, 4. So 4 is equal to under root 2 into 10 into h. 16 is equal to 20 h. Okay. So what do we get? So do we have 4 by 5 in options? No. Why? Then where did we go wrong? See, we are there. We have done almost everything right? Here we got in meters. Convert it into centimeters. Here the options are in centimeters. So 4 into 100 by 5, 80 centimeters, right? See, even if you reach here and if you cannot reach here, there is no point in doing all this stuff. So you need to take care of units very well. So be aware. See, in options he will give us 4 by 5 centimeters somewhere in between and he will choose that. So the 4 by 5 meters and 80 centimeters. Hope this question is clear. I think this is direct question. One hungry. Let's do a couple of questions and let's close, okay? So hope this question is clear. So let's try to do the next question, 97. Yeah, let's try to do a couple of questions, okay? See, monoatomic gas given gamma 5 by 3 at a pressure P1, 4 atmosphere. It is compressed adiabatically. So that its temperature rises from 27 to 327 degrees centigrade. Okay. The final pressure is being asked. So how do you find? See, we all know that PV power gamma is equal to constant is the equation for adiabatic process. So I'll try to tell you a shortcut so that you can use it anywhere. See, you try to use this relation for a adiabatic process whenever you find it. This got derived after a lengthy procedure. See, the relation between the pressure, volume and temperature goes this way. You can directly use it. So the initial pressure is given as 4. The final pressure is being asked. The initial temperature is 27. Convert it into Kelvin. What will it be? 27 degrees into Kelvin plus 273, 300. 327 plus 273, 600. Gamma by gamma minus 1. What is gamma? 5 by 3. 5 by 3 by 5 by 3 minus 1. So what do you get? 4 by Pf. 1 by 2. So 5 by 2. After simplifying, 5 by 5 minus 3, 5 by 2. So how do you find? See, if you try to look at options, actually if you want to solve this, you need calculator. Okay? Without using calculator, the options are given in such a way that they are in powers of 2. So 2 square is equal to Pf 2 power minus 2.5. Okay. See, I brought 2 up, it will become minus 5 by 2, so 2 power minus 5.5. So final pressure is equal to 2 square by 2 power minus 2.5. If I try to take it into numerator, 2 power 2 plus 2.5. 2 power 2 plus 5 by 2. 2 power. So hope you got this option. So let's try to do the last question for this session and close, okay? So hope this question is clear. So please try to copy down. See, this relation can be used anywhere, like for a adiabatic process we can use it directly. Okay. So let's try to do the last question and close the session. So let's try to do the other question, like 99. A gas at 37 degrees centigrade. So try to convert it into Kelvin. It's compressed adiabatically to half of its volume. V by 2 adiabatically. See, the moment adiabatically, you need to remember these two equations. The final temperature. So how do you find final temperature? So I guess you remember the previous equations that I gave. P1 by P2, V2 by V1, not V1 by V2, V2 by V1, gamma, T1 by T2, gamma, that is not R. So if you have this relationship in your fingertips, you can directly use it. Okay? So here volume is given, temperatures as being asked. So what is this Kelvin? How do you find? 273? Come on, what is the value of plus? Plus 273, what do you get? Initial volume was V and final volume as V by 2. So V by 2 by V whole power gamma. What is initial temperature? 310. Final temperature T final whole power gamma by gamma minus 1. So what is being asked? T final, right? So 1 by 2 310 by T final whole by 1 by gamma minus 1. So what is gamma? Gamma is 1.5. 2 minutes. See 1 by 2 310 by T final right, 1.5 minus 1. See, these two gammas gets cancelled, right? So what do we get? 1 by 4 310 by T final. So what is T final? 310 by 4. What is T final from there? 310 into 4. So what do you get? So you have to minus it from 273 and you get 165.3. See, this is the concept behind this, and basically you need to remember this and you are done with the problem. So let's continue in the next session. Hope this is your lunch. क्या है उसमें क्या है? Hope you are done. See, if you remember this formula, you can solve it. Okay.